It's one of the few theorems with a name.
What does that say?
It's called Pons Asinorum,
Which one? Base, and now this is isosceles.
which means bridge of acids. And the theory is that the proof was unnecessarily complicated, and that was just to weed out the students who couldn't follow it.
That's
So if you can't get across this bridge, then you don't advance to the second year in the school of Euclid. Okay, so what's next? Well, we know that the sum of the interior angles of any triangle is 180 degrees, right? So QPO plus PQO plus POQ, that angle, right? What is that? That must be 180 degrees, right? But we know QPO and PQO are the same, right? So I can say, well, how about substitute one for the other? So I'm going to say QPO plus QPO plus angle POQ is 180 degrees, which then I can combine these as a single thing, right? So this is by substitute. So this is the sum of the interior angles of any triangle. That's my abbreviation for that. And then this is by substitution. So when you're doing the deductive proof like this here, you should have a statement and its justification together. Right, so how many statements do I have here? 1, 2, 3, 4. Right, and each one of these is justified. We know these are the same because they're all radii of the same circle. We know the base angles of an isosceles triangle are congruent, Pons Asinorum, and we know that we can do the sum of the interior angles must be 180. That's also a theorem from Euclid somewhere, and a proposition, if you like, theorem, proposition, same thing. And we can do substitution then, equals, and we can combine like terms, right? So twice angle QPO plus angle POQ is 180. And this is combining like terms, right? Which is an example of the distributive property. How is that an example of the distributive property? If you have A plus A, you can think of that as 1 times A plus 1 times A, and then you can factor out the A, right? That's 2A. Like terms is essentially just the distributive property. Now what? Well, somehow we want to bring in something else. Yeah, I was going to say that I was going to do this differently, wasn't I?
Yes.
So we want to show that PQR is half of POR. In other words, we want to show that's a right angle, right? Because POR is a straight angle. So POQ plus QOR. Okay, so let's write that, right? So what do we know? Angle QOR plus angle POQ, what's that? Yeah, 180, it's a straight angle. So the justification for that is to say it's a straight angle. So they're supplementary, right? Together they form a straight angle, so that together their measure is 180 degrees. So then what? Well, then we can say that angle QOR is twice angle QPO. That's not quite what I wanted though, is it? So I can say, you know, so there's a variety of ways I can do this, right? But so this implies that angle QPO must be the same as angle QOR. And why? What's the justification for that? Well, I could subtract the same thing, then things equal to equal things are equal to each other. So I'm going to say subtraction and transitivity of equality, right? Things equal to the same thing are equal to each other. So just in brief, I will say subtraction and transitivity of equality. Things equal to the same thing are equal to each other. So I can subtract POQ from both sides here, subtract POQ from both sides here. Then I have 2 QPO is the same as QOR.
Wait.
Do you mean, shouldn't that be PQO, not QPO? In the second line right here.
You rewrote it to substitute.
Did I miswrite it?
Q.
Oh, you rewrote it to substitute?
By substitution.
Yeah, so I combined these, right? Oh, no, I combined those. Yeah, so I did substitution here, and then I combined these things and got twice QPO. So that's QPO, so twice this angle is QOR.
Maybe
right?
that I'm
Is
supposed
this
to
angle.
combine them. Oh, okay.
So, but that's not what I wanted to show.
So QPO and PQO are the same.
So how do I get what I want from this?
Yeah. That's right here.
Well, I could say
Yeah.
these angles are the same. They're different angles, right, from the other ones. And that the sum of these must be, I've got more work than I wanted. So what's a better proof of this? Well, what are the, maybe I should read the statement of the problem, they give me the answer. I ended up in the wrong place.
I think you mean that.
Explain why the central angle POR must be twice as large as the inscribed angle PQR, and the hint is, what kind of triangle is OPQ, and what then must be the relationship between its interior angles? OPQ is an isosceles triangle, and so its base angles are congruent, right? So draw a circle center O and identify PQR. And so the first case, we're going to have Q and R are diametrically opposite one another, so that O lies on one side of angle PQR. Sure. Please such a drawing and explain why the central angle POR, which is a straight angle, must be twice as large as the inscribed angle PQR. And I've ended up showing that this angle is twice that angle. Which is good, but I'm going to have a little more work, right? So, you know, what I like is the more general result. So here's my argument for this. I'm going to pick a point S here, right? And say, yeah, connect these like so, and then you'll see that by the same argument, which I'm out of space there, aren't I? So, I'm just going to move this over here.
It looks
Okay?
like, oh my god, I'm gonna make a kite.
By the same argument, we could say similarly, angle ROS is going to be twice angle RPS. Right, so this angle is going to be twice this angle, right? Yeah, it's good. It's just going to be the same argument, right? And so what does that tell me? Well, that tells me that the sum of these angles is half the sum of these angles, or this central angle is twice this circular angle. And I'm using these phrases, so the central angle is the angle subtended by an arc at the center, right? Circular angle is the arc subtended by an angle on the circumference. So the circular angle is half the central angle subtended by the same arc, right? So this arc QS subtends an angle at P, which is half the central angle, right? So thus, combining these, we're going to have that angle QOS is equal to twice angle QPS. Right, since this is twice that, and this